So today we are discussed about free electron theory of metals. What is a free electron? The free electron is nothing but the electrons occupied in the outermost orbitals, which are all called as free electrons. So what is the free electron theories? Based on the free electrons, the materials functions works, which is the material exhibit the properties, electrical property, thermal property, mechanical properties and dielectric properties, which are all based on this free electrons. So free electrons means the electrons occupied in the outermost orbitals. Based on the free electrons, the theories are proposed three types. One is classical free electron theory. Second one, quantum free electron theory. Third one, band theory. First one is classical free electron theory. This classical free electron theory proposed by Drude and Lorentz. The classical free electron theory proposed by Drude and Lorentz in the year of 1900. The Drude proposed this classical free electron theory in the year of 1900. After that, the Lorentz is expand these theories. The classical free electron theory expanded by Lorentz in the year of 1909. So this theory is called as classical free electron theory, which is proposed by Drude and Lorentz in the year of 1900. And this theory is based on this classical free electron theory. All the electrons moves with a constant potential, and it obeys classical mechanics. So, the classical free electron theory is proposed by Drude and Lorentz in the year of 1900, which obeys classical mechanics. Here, the electron moves with the constant potential. And this classical free electron theory is also, it is a macroscopic theory. It is a macroscopic theory. The next one is quantum free electron theory. Quantum free electron theory. This quantum free electron theory is proposed by Sommerfeld. in the year of 1928. And this quantum free electron theory is a microscopic theory. And this quantum free electron theory it obeys quantum mechanics. It obeys quantum mechanics. Already know that here also the electron moving with the constant potential. So, this quantum free electron theory is proposed by Sommerfeld in the year of 1928, is a microscopic theory. Then it obeys quantum mechanics. Here all the electron moves with the constant potential. The third one is band theory. The band theory is proposed by Bloch in the year of 1928. Then it obeys band theories, and this theory is called band theory or Brillouin zone theories. Zone theory or band theory, which means already know that the valence band and conduction bands. Here the electrons moves with a periodic potential. The electron moves with a periodic potential. The electron moving with the periodic potential. So overall we have to discuss free electron theories. There are three theories. One is classical free electron theory, quantum free electron theory, band theory. First one is classical free electron theories. It is proposed by Trudeau and Lawrence in the year of 1900. It is a macroscopic theory. It obeys classical mechanics, and this is a constant potential. Electrons moving with the constant potential. Second one is quantum free electron theories, which is proposed by Sommerfeld in the year of 1928. It is a microscopic theory. Then it obeys quantum mechanics, and here the electrons moves with the constant potential. Then third one is band theories of solids, which is proposed by Bloch in the year of 1928. Then this is also called as zone theory or Brillouin zone theory or band theories. Here all the electrons moves with the periodic potentials. So these are all the free electron theories. Now we have discussed about classical free electron theory. Classical free electron theory in a metals. Already we know that the classical free electron theory is proposed by Drude and Lawrence in the year of 1900. Already we discussed. Here they suggest that free electron theory is based on an atoms. Already know that is an atom, it is nucleus. These are all the inner electrons. These are the outer electrons, inner shell electron, outer shell electrons. Already we know that the metal contains n number of electrons. The metal contains n number of electrons. The nucleus. This is inner electron, the outer electrons. The outermost electrons, which are all called as free electrons. These electrons are nothing but free electrons. Already we know that a metal contains n number of electrons. Metal contains n number of electrons. Now, the Drude and Lawrence proposed some postulates. Drude and Lawrence proposed some postulates. The one is, in absence of electric field, all the electrons moves in a metal with all the directions, which is just like that. Let us consider a metal. Here, all the electrons moves randomly in all the directions. Metal, free electron. This is in absence of electric field. In absence of electric field. Here, all the electrons moves different directions. Right? During the process, the electrons collide each other. The electrons collide with each other. There is no energy loss. Why? Because this type of collision is called as elastic collision. This type of collision is called as elastic collisions. Which is look like that. A gas molecules in a vessel. Here one electron moves randomly in all the directions, which means the electron collide with each other. There is no energy loss. This type of collision is called as elastic collision. Now, the material subjected to an external electric field. The material subjected to external electric field, all the electrons moves in a same directions, which is opposite to the field directions. So during the process, the electron gets some energy, then the electron move in a particular direction. The direction is opposite to the field directions. This is like that. This is a metal. The material subjected to external electric field. Now, the electrons move towards the positive charge and opposite to the field direction. The field direction is this side, negative, positive. So, here the material, the metal this free electron, the metal subjected to external electric field, Now the electrons get some energy which is moved the same direction, that is towards the positive charge. Already you know that the electron gets negative charge. The electrons is always moved towards the positive charge and opposite to the field directions, right? Now the electron gets some velocity. That velocity is called as drift velocity. That velocity is called as drift velocity. The velocity is called as drift velocity. What is the drift velocity? A velocity acquired by a free electron in a particular direction due to applied external electric field. Due to applied external electric field, that is Vd is equal to lambda by tau. Lambda by tau. This is drift velocity. Drift velocity means a velocity acquired by a free electron in a particular direction due to applied external electric field, that is drift velocity. Vd is equal to lambda by tau c. Here the lambda is mean free path tau c. This is a collision time. Second one is, from this equation we can find mean free path. What is the mean free path? Mean free path. What is mean free path? The average time taken by a free electron between two successive collisions, which is called mean free path. From this equation we can write mean free path, that is lambda is equal to Vd into tau c. Vd into tau c, that is mean free path. Mean free path means the average distance travelled by a free electron between two successive collisions. That is mean free path. Next one is collision time. Next one is collision time. From this equation we can find collision time. What is collision time? The average time taken by a free electron between two successive collisions. The average time taken by a free electron between two successive collisions, which is called collision time. From this equation you can write collision time, that is tau c is equal to lambda by Vd. Tau c is equal to lambda by Vd, that is collision time. Next one is the relaxation time. The relaxation time is nothing but the average time taken by a free electron to reach its equilibrium position to its disturbed positions, which is called relaxation time. And the relaxation time is approximately 10 power 14 second. 10 power minus 14 seconds. Next, we will discuss about expression for electrical conductivity of a metal. Next, expression for a electrical conductivity of a metal. Already we know that the metals which contains n number of free electron. Now the material subjected to external electric field, the metals, the electron gets accelerated, which is towards the field, that is opposite to the field directions, towards the positive charge. Here already you know that what is electrical conductivity? The electrical conductivity is nothing but a number of electron flowing per unit area per unit time, which is called electrical conductivity. Here the metal, taking a metal which is subjected to now the material, that is metal, subject to external electric field, all the electron move same direction, that is towards the positive charge and opposite to the field directions, right. Here now the force experienced by the electron, the force experienced by the electron F is equal to E is a charge of electron, the capital E is electric field. See question number 1. Already you know that according to Newton's second law, the force F is equal to ma. Already we know that there is well known equation according to Newton's second law. F is equal to ma, that is mass into accelerations. Now equating equation 1 and 2, we will get that is ma is equal to E. ma is equal to E. Then we can simplify the above equation, that is A is equal to E divided by m. This is equation number 3. That is acceleration A is equal to E divided by m. This is equation number 3. Now the electron moving with an velocity v, from this equation 3, the accelerator is directly proportional to applied external electric field. If you are applying external electric field, the accelerator is increases. But the acceleration of electron collide with other positive ion and other free electrons, the loss of kinetic energy and velocities. Now the average drift velocity Vd, already we know that the average drift velocity is denoted by Vd. If the tau c is the collision time, if tau c is the collision time, then we know that acceleration A is equal to Vd by tau. A is equal to Vd by tau. Already we know the value A. From this equation we can find the average drift velocity. This Vd is equal to A into tau. Vd is equal to A into tau. Now see equation number 4. Substituting equation 3 in 4. Substituting equation 3 in 4, that is drift velocity Vd is equal to E tau divided by m. E tau by m. This is equation number 5. Now, the current density in terms of drift velocity. The current density Jx equal to N E V D. Current density Jx equal to N E V D. This is equation number 6. Equation number 6. Now, substituting equation substitute equation 5 in 6, that is Jx equal to N E into Vd value E tau by m. Then simplify the above equation. Jx equal to N E into E square E tau divided by m. This is equation number 7. Now, the current density in terms of Ohm's law. The current density in terms of that is Jx equal to sigma E. Jx equal to sigma E. This is equation number 8. Now, equating equation 7 and 8, that is sigma E is equal to N E square tau E divided by m. Now, E cancel each other, then sigma is equal to N E square tau by m. This is equation number 10. This is 9. The equation 10 represents expression for electrical conductivity of a metal. Expression for electrical conductivity of a metal. That is sigma is equal to N E square tau by m. Next topic, expression for thermal conductivity. First we are going to what is thermal conductivity. The amount of heat flowing per unit area per unit time at temperature gradient. This is called thermal conductivity. Thermal conductivity is nothing but thermal conductivity Q is equal to Ka into dt divided by dx into T. From this equation we can find the thermal conductivity K, the value of K is equal to Q divided by dt by dx into T. This is thermal conductivity. Now we discussed about the expression for a thermal conductivity of a metal. Expression for a thermal conductivity of a metal. Now let us consider a metal rod with the length lambda. This is A, this is B. A is hot end, B is cold end. You know that the heat always conducted from hot end to cold end, hot end to cold end. Now the average velocity of an electron V, already we know that. Now the heat conducted from the hot end to cold end, that is heat conducted from hot end to cold end, that is A to B. Now what is the amount of heat at the hot end A, that is the average kinetic energy at A, that is 3 by 2 kBT. See equation number 1. The average kinetic energy at A. The temperature at the hot end is T. Here the temperature at cold end is T minus Tt. Now the average kinetic energy of at A is 3 by 2 kBT. Similarly, the average kinetic energy at cold end B, which is equal to 3 by 2 kB into T minus dt. See equation number 2. You can expand this equation is equal to 3 by 2 kBT minus 3 by 2 kB dt, equation number 3. Now the energy now the excess of kinetic energy in a metal that is 3 by 2 kBd, it is the average kinetic energy of metal A minus the average kinetic energy of metal B, that is 3 by 2 kBd minus 3 by 2 kB dt. Then you can write the excess of kinetic energy of a metal is 3 by 2 kB dt. This is equation number 4. Here 3 by 2 kBt minus 3 by 2 kBt. So remaining minus of minus plus 3 by 2 kB dt. This is equation number 4. Now, number of electron crossing per unit area which means the heat conducted from hot end A to B, which is the conductor, the electron with all the 6 directions, which means just like that. So plus x plus y, minus z plus z. So here the movement of electrons move with all the 6 directions. So the number of electron crossing per unit area is equal to 1 by 6 n into v. 1 by 6 means the movement of electron in all the 6 directions. N is number of atoms, number of electrons. This is velocity of electrons. This is equation number 5. Now, the number of excess of energy carried by the electrons carried by electron, that is 1 by 6 n v into the equation 4, that is 3 by 2 kb dt. Equation number 6. You can simplify the above equation, that is 1 by 4 n v kb dt. So the number of crossing electrons carried out the electron from A to B. This is A to B. Similarly, the number of cross section of the energy carried by electron at B to A. The number of excess of energy carried by electron from B to A, which is similar like that. minus 1 by 4 n v kb t. So, equation number 7, equation number 8, 7 and 8. Hence, the net amount of energy transferred from A to B, total amount of energy transferred from A to B, which means one by 4 n v kb dt minus 1 by 4 n v kb dt. So, you can write 1 by 4 minus of minus plus 1 by 4 into nv kb dt. Then the total amount of energy transfer from A to B is equal to 1 by 2 n v kb dt. It's equation number 9. Already we know that in thermal conductivity, Q is equal to K dt by lambda. Equation number 10. Now, equating equation 9 and 10, that is K dt by lambda is equal to 1 by 2 n v kb dt. Now, what is the value of K? K is equal to 1 by 2 n v lambda kb. dt cancel each other. This is equation number 11. Already we know that the collision time tau c is equal to lambda by v. From this equation we can find the lambda equal to tau into v. Equation number 12. Now, substituting equation 12 in 11. Substitute equation 12 in 11. Substituting equation 12 in 11, it is 11 equation K is equal to 1 by 2 n v, here v square tau k b. So, equation number 13. The equation 13 represent expression for thermal conductivity of a metal. Already you find the value of expression for electrical conductivity, then expression for thermal conductivity. Now Wiedemann Frantz law. So what is Wiedemann Frantz law? Wiedemann Frantz law is nothing but the ratio between thermal conductivity to electrical conductivity. The ratio between thermal conductivity to electrical conductivity. That is K by sigma is directly proportional to absolute temperature T, then K by sigma is equal to L into T. This L is Lorentz number. Already we know that the expression for thermal conductivity, that is K is equal to 1 by 2 N V square tau Kb. This is equation number 1. Already we know that electrical conductivity, that is sigma is equal to N E square tau divided by M. This is expression for electrical conductivity. Now the Wiedemann Frantz law is the ratio between thermal conductivity to electrical conductivity. We know the value of thermal conductivity, that is K by sigma is equal to 1 by 2 N V square tau Kb divided by N E square tau by M. Now we can simplify the above equation. The Wiedemann Frantz law is K by sigma, which is equal to the thermal conductivity and electrical conductivity. We can simplify the above equation. K by sigma is equal to, the remaining is 1 by 2 this M V square Kb divided by this E square. Already we know that of M V square is equal to 3 by 2 Kb T. Now substituting this value, thereby equation, that is K by sigma is equal to, instead of this value you can substitute 3 by 2 Kb to Kb square by E square into T. Already we know that here you can see the Wiedemann Frantz law is the ratio between thermal conductivity to electrical conductivity is equal to L into T. This L is Lorentz number, which means you can see K by sigma is equal to 3 by 2 KB square by E square into T, which means this is L. That is L is equal to 3 by 2 KB by E whole square. This is Lorentz number. The value of Lorentz number is, we can substitute these values. L is equal to 3 by 2 KB, Boltzmann constant 6.626 into 10 power minus 34 divided by charge of electron 1.6 into 10 power minus 19 whole square. We can substitute these values. KB, Boltzmann constant 6.626 into 10 power minus 34 divided by charge of electron 1.602 into 10 power minus 19 into whole square. We get the answer is, the Lorentz number L is equal to 1.22 to 10 power minus 8. This is the value of Lorentz number. This Lorentz number, we get only half of the value of experimental values, half of the value of experimental values. So which means by using the classical theory, you will get the unit of Lorentz number. This is only half of the values, we will get the Lorentz number. But according to quantum theory, the Lorentz number, the value is L is equal to 2.44 to 10 power minus 8, which is the accurate value of experimental values, which means by based on the quantum free electron theory, you will get exact value, but the classical free electron theory, we will get half of the values. That's why we are going to quantum theories. So this is the one of the failure cases of classical free electron theory. By using classical free electron theory, you will get only half of the values of experimentals.